difference between batch processing and real-time processing. You know that already. And this is how you compare what is this MapReduce with Spark, right? So day one's data you are analyzing on day two because it is batch. You can't do it on. When it is in Spark, it is like day one, or day two, or real time you can analyze. No big deal. And these are the comparison between batch and stream processing. In batch, queries or processing over all or most of the data in the data set. Stream is like in a window. You mention the batch size or the event where only it gets processed. The data size is large. Here it may be small. Performance can be hours, but here it has to be millisecond. And analysis complex. Here it is simple response functions aggregate. So many people ask me, like when I show demos and all, like why don't you have a very complex demo? So there can be complex demo, but you don't really do complex analysis because your analysis time should be less, right? So if my analysis is taking 1 hour, then there is no point in doing something real time, right? But yeah, it happens. I mean, in ML side and all it happens, but normal regular Spark streaming side, your analysis is very basic, like simple response function or some aggregation you do and respond it, so on and so forth. This is what I was talking about. So earlier we used to do MapReduce based processing, so which was really bad. MapReduce is inherently batch, need for a data source as disk, put latencies in the processing. Stream needs multiple transformation, which cannot be expressed on MR. Overhead in launch of a new MR job is too high. So did you discuss in the Spark class about caching? Now in Spark streaming also you can cache it. Streams you can cache it and we do it sometimes. Now in caching, you have caching levels. So when you say persist, this persist method can take different levels. By default it is memory, RAM. So it will store it in RAM. And then you have RAM plus hard disk. And then you have hard disk alone. Like you can mention something called storage level. I'll show you. So you can say persist dot disk or dot disk plus RAM. Now, so that's what I'm saying. So in one class, somebody asked like, where will you use a disk? That's what. So if you're having SSDs, then only the disk factor can be applied. On a regular cluster, you don't say disk. Then it is very slow. It is as good as reading like MapReduce. So when you build your cluster on Amazon and all, you get SSDs for free. Most of the instances will give you SSD for free. So that SSD you use only for caching. The regular hard disk you will be using for other jobs, but SSDs you will configure for only caching actually, right? So we have done that once. And this is batch and RTA integration. Many environments require processing same data in live streaming as well as batch processing. So existing frameworks cannot do both. So the problem is that I want to combine batch and real time together, right? Why do I want to do that? A classic example is like applying machine learning. So maybe you have already trained your model based on some batch data, right? And then you're getting some real time data, right? And maybe you have some customers who are doing credit card transaction and you build a machine learning model based on the customer's ID and something, it can predict whether it is a fraud or not, right? So when that customer is actually transacting real time, you might want to combine or look up the machine learning model and combine them together. So batch and RTA integration, existing frameworks cannot do both, right? And extremely painful to maintain two different stacks. That's what I'm saying. If you're using Storm, for example, Storm can actually do real time, no doubt about it. But there, if I have to implement machine learning, I have to probably write it in Python separately, then implement it separately, then integrate them together. Because Storm doesn't understand about machine learning. So two different stacks you have to maintain and then make them work, which is really bad actually, right? So double the implementation effort, double the number of bugs with this. That is where Spark can do everything. We will look at fault tolerant stream processing later once we see stream processing. Okay, and this is just an introduction slide on Spark. You already know what is Spark. I don't have to talk about it. Now, coming to Spark streaming, there is a couple of things I want to tell you. your syllabus actually covers original Spark streaming, meaning there is something which is new. Okay, so I don't want to be a spoil sport, but yes, the Spark streaming we are learning is legacy now. If you look at the documentation, it will be marked legacy. It is old, meaning community says don't use it. It's not like don't use it, but you can use it. They have introduced something called structured streaming. Yeah, so if I go to here and go to documentation, latest release. Okay, so this is official Spark site. If I scroll down, what you see here? Old API. Well, it's not really old, to be very fair with you, because I have never seen anybody. So this is what we are doing, and they say there is something called structured streaming using dataset, data frame, and newer API than the dstream. That's okay. Even I understand there is something called structured streaming. Okay, but people have not actually started using structured streaming. So at least I have not seen. Maybe my mistake, but just be aware there is something called structured streaming. The idea is very simple. What is structured streaming? You create a stream, same way as you do in Spark streaming, but yeah, it will create a ever-growing data frame. Meaning the data comes in, right? And you give some structure to the data. And in structured streaming, it will create a data frame and push the output to the data, push the output to this data frame that is in memory. You are not storing anywhere. So this data frame will get bigger because you are continuously pushing. So you can do real-time SQL queries on the data. Real-time SQL queries. So previously what I used to do, I get the data, I save it somewhere, and then I query that table, right? So it's not 100% real time. But now what I do, I create a table which is in memory, which is growing every 5 seconds or 10 seconds, depending on a batch data. And I can write streaming SQL queries on this table. So that is the idea of structured streaming, basically. No, I mean, this is the basic idea. I mean, there are some more fault tolerant principles and all behind it, and you can save it also. But you can query the data using SQL as and when the data comes in. Previously, that is not possible. I get the data, I convert to a data frame, I save it in a Hive or something, then I query. But now, as and when the data comes, I'm able to run SQL queries. And those queries are not regular queries. So, my recommendation is just read a bit on structured streaming. I don't want to get into that, because if I teach that and this, then the session will not be enough, first of all. And also that's not required at this point in time. Maybe later people might get used to this.